Hi, Larry, W6WUH in California. We're looking at the backside of the Gonset Commander Mobile AM/CW transmitter. Just to give you an idea of the scale of this thing, here's a little microphone. Probably robbed off a, I don't know, it says Tate on it. I don't know, robbed off a 2-meter rig or a CB radio or something. But anyway, that gives you an idea how small this thing is. So what I wanted you to do is look at the rear panel of this and to give you a little idea of what it takes to hook these things up. One of the reasons that mobile receivers and transmitters aren't put on the air very much is that they can, the mobile installations were enormously complex. There were multiple power supplies, high and low B+ power supplies, and relays and solenoids switching these things on and off, and antenna relays, and field strength meters, and antenna tuning units, and it went on and on and on. And doesn't have to be that complicated when you've got an AC supply to run it, and even easier on the bench. But anyway, let's take a look at the thing. This has some interesting provisions on the power connector on the back, and a couple of features that, at least one feature that I've never seen anywhere before. And that is that the cathodes for the oscillator and the final amplifier are brought out to pins on the back. And they're not just grounded in the radio, but they're grounded through these pins on the connector on the back so that they can be controlled remotely. And what that allowed you to do would be, say, ground the cathode of the oscillator so you can use it to spot your frequency on a receiver. And I'm not quite sure why they had it for the final amplifier, but clearly it lets you run the oscillator without running the final and putting out RF. And it may also have simplified things from a power supply standpoint if you're using a common power supply for receiver and transmitter, rather than having to hot switch B+ between the receiver and the transmitter. Conceivably, you could just ground the cathode of the final to make it transmit instead. Not quite sure why they did it, but that's my thinking. So anyway, on the back here, you've got the ground for the radio, the B-, common for the filaments, and the B-. You've got the filaments, in this case 12 volts, and you have separate B+ connections for the oscillator and modulator, because they're limited to about 300 or 315 volts, and a B+ line for the final amplifier tube, the 6146, which can be run as high as 500 or 600 volts, but I think Gonset's idea was that you'd run it at 425, 450 with the dynamotor. Since the modulator tubes in the oscillator won't take 450 volts, they separated them out. But if you're running on an inexpensive power supply, like a single vibrator supply that only supplies 300 volts, then you'd connect those two pins together. It's actually the bottom one down here and this one for the oscillator, modulator, and the final. You just jumper those two together, run it all on 300 volts, which is basically what I'm doing here now. So I've got this kludgy thing here where I've got two clip leads here for the cathodes of the oscillator and the final, and they're clip leaded to ground. I've got a common ground for the filaments and the B minus, and then I've got the B plus. This is clipped together, and all of this going up to this this adjustable power supply here. So I've got this power supply, which has been modified to run mobile rigs exclusively, and so it'll give me a high B plus of 400 volts and a low B plus of 250 or 300. So that's ideal for running mobile receivers, converters, and transmitters at 400 volts of B plus. So this is a very flexible little transmitter. It'll run on anything from probably about 250 volts up to well, 300, and run everything, or you can run the low B plus at 300 and the high B plus at whatever you want, but 450 is probably practical. Over here is the crystal carbon mic selector switch. In the crystal mic position, your crystal or dynamic mic is just driving the grid of the first section of the 12AT7 in a conventional manner. When you switch it over to the carbon mic position, it reconfigures the input of that too and runs it grounded grid. And then the carbon mic is actually in series with the cathode, and the cathode current provides the voltage that the carbon mic needs to work. Otherwise, it would have to have a battery, bias battery, or dropping resistor off the 12 volts. But so that's one of the neat ways of running a carbon mic without having to have an additional special carbon mic input transformer, which is not a bad way to go, but it's another part, and there's no room. So there we go. I'll pull these clip leads off here real quick while with the camera running, and just let's see, we're not plugged in. We'll flop this over. Let me put the camera down. We'll look at the wiring underneath. Well, that's pretty poorly done, but let's try this. Okay, so here we have the guts of this little baby, and in terms of recapping, there's hardly anything to do. This 3-section electrolytic, as you can read, it's 20 microfarads at 25 volts, so that's probably a cathode bypass cap for the modulator. 10 at 150 and 15 at 450. I'd have to look in here. I don't have a parts list for this thing, so I'd have to follow the wires all out to see where they go. But I think shouldn't be too hard to figure out. This is actually a buffer cap across the secondary of the modulation transformer, so that's limiting the high frequency response a little bit. Pretty straightforward. Here's the oscillator coil, and the band switch, just selecting taps on that oscillator coil, depending on what band you're working on. The oscillator tuning capacitor, not too much to it. There's the oscillator tube, the 6AG7. That's the final amplifier tube, the bottom of the 6146. Here's the mic amp speech amp tube, 12AT7. The bottom of the driver transformer, so we got single plate from the 12AT7 going to this transformer so it can drive the grids of the 7C5s in push-pull. And here's the modulation transformer. There's the back side of that little 10-pin Jones plug, and you can see the pin numbers 2468 across the top, and 13579, 24681 and 13579 on the bottom. I haven't got this this plug. It's kind of an unusual one. It's only a 2-row plug, so I've got to find that. Here's the carbon mic, crystal mic selector switch, mic gain in the back. Little slide switches, nothing nothing exciting. Now, if you run this thing on 450 volts on the plate, you've got to change this screen dropping resistor for the 6146, and let's see, somewhere I've got the dope on doing that. It's either going to be 10 ohms for every 10 volts or 50 ohms for every 10 volts to drop that from 450 to whatever it was for the screen, 225, I think. But that's the only change you have to make. Let's take these off of here and make it a little easier to look at this. So here's the here's that 10-pin Cinch Jones plug, and I've got this marked here. So across the top you can see that you've got 12 volts for the filaments, the high B+, push to talk connector. So you're going to want to run an antenna changeover relay, and the mic switch just comes out on that pin right there. These 2 pins on the end are connected to on-off slide switch in the front panel, and that lets you like turn your vibrator supply on and off, or control any other thing really that you wanted to do. On the bottom, I can't read my own writing. Oh, on the bottom, that's the other half of the on-off switch, and then I'm not sure, but I have to look at the schematic here. Let's see which ones. Oscillator cathode is pin number 1, so that's over here. And PA cathode is pin number 2. So these 2 ones on the outside have to be grounded to energize the oscillator and the final amplifier. Here's the chassis ground, filament negative, B-. Of course, that's all just tied to ground. Pin, what is it? Pin 4 and pin 8 are just tied together right inside here. You can see that they're tied together and tied to ground. So filament ground, B-, chassis ground, all the same thing. So that's it. It's not very complicated at all. Let's turn it back over here because I just can't stand to see it looking like that. And here's the nifty little case that it lives in, with these distinctive little screen grills in the back, and a lot of perforations in the bottom to let the heat out. Nice compact little package, and I was lucky enough to get this VFO. I actually got the VFO before I got the radio. But anyway, there we go. That's the general layout. The next thing we're going to do is experiment with some of these plug-in coils that I have, and see if we can get one that'll work on 80 and 40. Somewhere on the net there's a recipe for winding your own coil, so I'm going to take a look and see what that says in terms of number of coils and coil diameter. And here's the little antenna coupling coil on the back. This is a standard bud coil. Here's another nice bud coil, pretty nice. And same thing with the ceramic base. Now this says 40 meters here. It's got a lot of turns on it. If you look at the coil for 20, 15, and 10, it's only got about 5 turns. and it's only about 1.125" in diameter. It's not a large coil at all. So I think what we've got is a lot of capacity relative to the amount of inductance, and at a very wide range of tuning. So I have a feeling that it means that these coils are not going to be very critical, and that there's going to be some place in there where the thing is going to resonate just fine. So it's just finding one that has enough inductance that it will work on both 80 and 40. So that's the story for this for now. Next time, next video, I will have separated out the B+. We'll put about 400 volts on the 375 or 400 on the final amplifier, 300 on the modulator and oscillator, and we'll see what kind of power it makes there. I'm expecting to see something around 15 to 20 watts output, assuming I can get a, well, that's what I think. We'll see what happens.